Okay, welcome back. So this is your fourth experiment in looking at pure substances and mixtures. So a couple other terms we also learned was the concept of a solvent and a solute. Okay, and essentially you learned that a solute is the thing that dissolves into something, and the solvent is the thing that the solute dissolved into. So a classic example is we did our chocolate milk experiment where we took milk, which that would have been the solvent. So the liquid generally is the solvent. The chocolate drink powder is the solute, and then when we mix them together, that's how we create a solution. So solution is comprised of the solvent and the solute. So the solvent is the item that the solute dissolves into. The solute is the item that dissolves into the solvent. So the milk was the solvent, and the chocolate drink mix was the solute. So we're going to look if all solvents are alike. So we're examining two solvents, and very important with this one, okay? You never ingest anything, you never sniff anything, and you're very careful with this, okay? So it's very, very important. So what we'll be doing again is mixing stuff and creating and seeing if all solvents are alike. Because it's important to know if all the solutes will dissolve in solvents. And that allows us, when we're making things or creating things, be it industrial, be it through food, be it through a number of items, how items react. Okay, so you're going to have two beakers. Okay, one is going to be filled with water, and the other is going to be filled with ethyl alcohol, or in this case, rubbing alcohol. All right, so it's very important that when you're using this, you do not ingest anything, don't sniff it. We're all familiar with it. Okay, it's very, very important. And again, everything will be at the back table. You'll have four substances. Again, creating a chart. Science, lots of charts, allows us to compare things, good visual aid. You'll have sugar, salt, drink crystals, cocoa powder. Again, you take your parchment paper, lay it out, get a plastic spoon. Okay. This one is very critical in your observational skills. Okay, you really got to be critical with your observational skills on this one. And as I was talking about in the previous experiment, in looking at how much I put into something, so the amount I enter into an item and what I see is extremely important. Okay, this is critical, critical, critical. Also the amount of water. So usually we use 100 milliliters of water and roughly I would say 150 ethyl alcohol. So also look at the amount of water or solvent you have. So if you have a lot of solvent, and there's not a lot here, if you put a lot in here, it's obviously not going to dissolve as quickly because, and we'll talk about that later on in another experiment, but be cognizant of the fact that if I have a lot of liquid or a little bit of liquid and I dump a whole bunch in here, obviously it's not going to dissolve. We all kind of know that if we're making Kool-Aid or anything like that. So try to, when you're looking at your ethyl alcohol and your water, put substances that are relatively equal. Okay, or in math, we say the ratios are the same. So if I have this much ethyl alcohol, I'm not going to dump a whole huge thing of Cool Shot in there. All right, so what I want you to be looking at is when I take my original amount. So if I'm taking, a spoon of sugar and I'm dumping it into my water, and again I give it a stir. As I observe, okay, I may have to stir it longer, right, to see what happens. And again, we're going to talk about this process too, because this is called agitation, last experiment. And then I'm going to kind of see. Now, there may be some stuff sitting at the bottom, okay, because I just haven't stirred it long enough, right? Or, oh, there's Murphy Brown. He's coming across. There you go. Thanks, Murphy, my assistant. You saw Gary in the visual. That's Murphy. The fish doesn't leave the tank. What you're going to say is, okay, I can see right now a bit of sugar at the bottom there, but I know that the original amount I put in is not equal to the amount that's down there. So then I know that this sugar dissolved, okay, for example. And that would lead me to believe that the solvent, the water, is dissolving the solute, the sugar. So this, I would say, is creating a solution. And if I continue to stir, I'd probably get rid of that. Or if I added more water, and we'll look at why that happens. There's a reason for this to happen, but I just want you to observe whether these two solvents act the same. So once I've done that for the sugar, I'm going to do the same thing for the ethyl alcohol. So I'm going to put in the amount. And I'm going to look and say, okay, this is kind of how much I have in my spoon. All right, I'm going to dump it in here, give it a stir, and I'm going to compare and say, okay, I'm not going to compare it to the water. I'm going to say, do I have the same amount of crystals? Is it relatively the same? A couple of things we can do because they can be hard to see. One, you have the magnifying glass at the back. You can use the magnifying glass. For this experiment, it's critical that you bring a flashlight. Okay. Unfortunately, I can't provide flashlights for everybody, but I have a flashlight here. It's critical you bring a flashlight. Okay. And what you're going to do then is turn your flashlight on, hit it with the beam, and really kind of see. Because what happens is if stuff hasn't dissolved, the light will reflect off the crystals. Because the crystals are kind of white, the water is transparent, so we can't. Sometimes it's hard to see. So bring a flashlight or use your phone, get a flashlight app, and you really want to make sure you use a flashlight with this experiment. So make sure if you're doing this in a group, you talk things through and you say, okay, somebody bring a flashlight for tomorrow or an iPhone app or whatever. So when you're observing specifically the ethyl alcohol, really take a good look at it, really look and say, okay, do I see the crystals? Hit it with the light, see if there's any crystals reflecting off it, and say to yourself, okay, and if I keep stirring it, does something happen? Does the same amount stay there? So it's really, really critical. Because at the end, you want to compare whether both of these solvents, the water and the ethyl alcohol, react the same. Okay, react the same. So am I going to create a solution with each of these items, which means that when I add sugar into the water, salt into the water, and the other items, and I stir it up, I only see one type of particle. Or I notice that there's particles that have dissolved, right? They're no longer existing there. Whereas in the ethyl alcohol, will all these items dissolve? And of course, you repeat this experiment 4 times. And in your chart, you would have the 4 items, particles visible in the water, particles visible in ethyl alcohol. And just like a quick yes or no for that experiment, okay? In terms of the process, same idea. You're going to take this back, dump it in the waste bucket. You're going to dump this one back in the waste bucket. With the ethyl alcohol, I'm going to have some paper towels at the back. Okay, you're not going to put water into the ethyl alcohol beaker because then you'll contaminate this beaker. So what you're going to do is take, you're going to dump this out, and you're going to take a paper towel, and you're going to clean out the beaker. Okay? Do not put the ethyl alcohol beaker in water, because what you're then going to do is coat the beaker with water, and we're not going to have a true scientific experiment. You're cross-contaminating. So you just dump this out, take the beaker, take the paper towel, give it a good wipe, all right, get it as dry as you can, and then ethyl alcohol. Very, very important, because it might skew your results, and that's bad science protocol. All right, and then you come back, repeat. I'll have ethyl alcohol at the back. Again, you don't need a lot, okay? And again, look at the amount of ethyl alcohol you put in compared with the amount of powder you put in. Right? They should be the ratio should be the same. So we don't have a lot of ethyl alcohol because you don't need a lot, so you don't have to pour a whole bunch in there. And really observe, use your magnifying glasses. Make sure you bring a flashlight to that experiment, so prepared ahead. At the end, what I want you to do is tell me, first of all, are these solvents the same? And if they aren't, why do you think the 2 solvents aren't the same? So if something is say something doesn't dissolve in water but dissolves in here, why? Or vice versa. If something doesn't dissolve in ethyl alcohol but dissolves in water, why wouldn't they? They're both the same chemical composition, so sugar, sugar. Why is it dissolving here? Or why is it not dissolving here? And the same question. Okay? So you have your chart and then a paragraph trying to figure things out. You can do a bit of research. You can take a hunch. All right? Think about it in terms of the molecular structure. So when we talked about liquid, solid, and gas, we talk about the bonds, right? We said in terms of liquids, right, the strength between the molecules aren't as strong. Maybe that has something to do with it. I don't know. You tell me, okay? Again, just to reiterate, careful with this, all right? Please, when we're dumping, do not rinse the ethyl alcohol beaker out with water. Use a paper towel. Make sure you bring your flashlight, magnifying glass, prepare for this one. If you don't have it, it's not going to work as well, okay? So make sure you are prepared. Flashlight, magnifying glass, and that's it. Happy dissolving.